Hello and welcome to this video on solving applied problems involving absolute value inequalities. So in this video I have pulled two examples from an intermediate algebra textbook that involve an absolute value inequality that I'm going to have to solve, and then we'll just interpret them. So these are pretty simple word problems where the inequality in question is already stated for us, and we're just asked to solve the inequality in question and also then interpret the solution. Write a full and complete, write some complete sentences describing what the solution is saying. So here we go. So in my first example, I have the inequality. And here it is again given to us. Again, both of my examples today involve an inequality that is given to us, so we don't have to do a lot of work. I'm sure in a future video I'll look at some application problems, word problems, where we have to write an inequality or an equation involving absolute value ourselves, but for right now they're given. The inequality, the absolute value of x minus 4 is less than or equal to 1/32, represents the acceptable belt width x in inches for a belt that is manufactured for a pulley system. Alright, so these belts are being manufactured, and each one is x inches wide, and we're asked to determine what's the acceptable belt widths. Right. Well, they said again, they set up for us, they gave us an inequality describing to us the acceptable belt widths. Anything outside these widths will be rejected by the manufacturer and probably not sold. Maybe tossed in the trash or recycled. But we're looking for what belt widths are acceptable. So all we're doing then is solving for x, because notice they said, determine the acceptable belt width or belt widths. That was the variable x, right? X was given as belt width up here. So we're just solving this inequality for x. All right, so my inequality is an absolute value inequality involving is less than or equal to. And I have put up a video prior to this, a couple videos ago. If you'd like to look at that, please do, because I'm going to kind of go through this a little more quickly than I would have if I'm just showing this for the first time. The absolute value of x minus 4 is less than or equal to 1/32. I might even change that to a decimal later. 1/32 is a very tiny number. All right, 1 divided by 32 is about 0.03125. I just punch that in the calculator. I'll write that off to the side here. So 1/32 0.03125, right? So a little over 300ths, right? A little over 300ths is this is 3,125 10,000ths. Or no, not 10,000s, that's thousands, 100,000s, my apologies. That's 3,125 100,000ths. Okay, so hopefully recall this from again a prior video. When we have the absolute value of some expression, right, which I'm going to call just a, being less than or equal to some non-negative number, which I'll call n for non-negative number, which is 1/32 is a non-negative number. This statement here is equivalent to the following compound inequality involving the word and. And you can write an equivalent compound inequality just by thinking of what absolute value means. All right, absolute value of a real number, you can think of that as the distance from 0 on a number line. So what numbers that could represent this a, what numbers have an absolute value less than n units? Well, that means that these numbers A are, closer to 0 than n units. In other words, A would be between, the opposite of n and n itself, right? If I were to draw a number line under here, show you what I mean by this. Here's a number line and there's the number 0. What numbers have an absolute value equal to n are, n itself, and we're again assuming n is a non-negative number, so notice this to the right of 0. That's n units away. That has an absolute value equal to n. And then the opposite of n, right? The opposite of that number, same distance on the other side, that also has an absolute value equal to n. And so the numbers we're talking about here are all the numbers in between, right? All these numbers are the numbers that A can represent, right? Everything that's closer to 0 than n units, right, has an absolute value less than n or equal to n, right? We're also including n and negative n here. I'll put little dots above those. All right, but this is what we're going to be doing in this situation. Taking in this inequality with the less than or equal to symbol and writing it as this equivalent compound inequality involving the word and, right? Remember these connected or compactified, I shouldn't say compactified, that's another thing. But this compactly written inequality, connected inequality, is, two inequalities at once connected by the word and. Negative n is less than or equal to a, and a is less than or equal to n. All right, so over here, I have the absolute value of x minus 4, which the x minus 4 is like the a over here, is less than or equal to, this non-negative number 1/32, or again 0.03125. That's the n. So this is equivalent to, I'm just going to draw a little double arrow instead of writing out the words. This little thing will mean is equivalent to. Well, in order to have an absolute value less than 1/32, the number here, the number inside, right, x minus 4, must be between 1/32 and negative 1/32. Right, and also equal to, right? They have less than or equal to, so or equal to, or equal to. So we set up this equivalent compound inequality. And then I'm just going to solve this. Now, again, I've put up a video before on solving these compound inequalities that are connected like this, with the word and involved. You're just trying to solve these two at the same time and then take the intersection of the solution sets. But solving these two at the same time, you can really just get the variable alone in the middle, and what you do to the middle part, you do to the outsides as well. So if I were solving for x here, and get x alone in the middle, I would just be adding 4 here to get rid of the negative 4, and then doing the same to the other parts. Okay. All right. Now, when you add, right, when you add two numbers, you need a common denominator, and the denominator of that fraction is 32. So let's see off to the side here, 4, right? 4 over 1, really. When you think of 4, it's like 4 over 1. I'd multiply the top and bottom by 32, and that'd be 128 divided by 32. Right? 128 30-seconds would be 4. Right? So when I take on the left side here, negative 1 30-second plus 128 30-seconds, the left side would be 127 30-seconds is less than or equal to, and in the middle now I have just x, and that's less than or equal to, and then over here I have 1/32 plus 4, or 1/32 plus 128 30-seconds. And you keep that common denominator and just add the numerators, 1 plus 128, 129 30-seconds. All right. And I'll write these as a decimal as well. Just because. So you could also say this is x is between, this is 4 and 1/32, so 4 plus, 0.03125 over there. So 4.03125. And over here, this side is just 4 minus 1/32, right? Positive 4 and then a negative 1/32. So that would be 4 minus 0.03125. So that'd be 3 let's see, 99687 96875. Okay. And there we go. You can leave it as the fractions or decimals. They're the same number. And now, these are the solutions to this inequality, but they're not an answer to a problem, right? The word, anytime you have a word problem, and I've mentioned this in other videos of mine with word problems involved applications, when you're given a word problem, you should answer the questions posed, or you should determine the things that they ask you to determine through the use of complete sentences, and also put units on every number you write so that each number actually has some meaning. All right, so remember what X represented, belt width, right? And it was in inches, right? Back in the problem, belt width X in inches. So when they're saying here, determine the acceptable belt width, well, that's the solutions to our inequality here. So the acceptable belt width for this manufacturer is a belt width between 3.96875 inches and 4.03125 inches. And that's how I'm going to write the answer to this question, right, in a complete sentence. So the acceptable belt width for this manufacturer is a width between x being the belt width, right, is between here 3.96875 inches. Let's put IN period, right, the abbreviation for inches, and 4.03125, 4 1/32 inches. And then I'll throw the word on comma inclusive. Throwing the word inclusive there means that the belt width is allowed to be between these, but also including these, right? Notice the or equal to, right? So those numbers are actually included as acceptable belt widths for this, this particular manufacturer. All right, so think about it a little more. So this manufacturer is, creating these belts for this pulley system, and if a belt comes out of a machine when they're done, and they measure it, they measure the width, and and the width was 3.8 inches, they throw it away, right? It wouldn't be allowed, wouldn't be accepted. If it was 4.1 inches, it would be too big, too wide, and it wouldn't be accepted, right? It has to be the belt when it comes out of the machine, when it's done being processed, done being manufactured, has to have a width, from this amount of inches to this amount of inches. So I mean, the perfect dead-on middle amount would be 4, right? Exactly between these two. If it was a 4-inch width, would be that'd be fantastic. But there is some leeway here. There is some tolerance, and the tolerance is 1/32 on both ends. 4 plus 1/32, 4 minus 1/32 of an inch. Okay, great. So again, word problems, please answer your questions in complete sentences and have units, right? And those inches have units on your numbers, so that they actually have meaning, related to the problem. All right. So my next example, the last example from this video, is another word problem, again, where we're given an inequality and asked to solve the inequality with the absolute value symbol and interpret it, right? Say what it means for the problem, write out a full sentence, and throw units on the numbers so that they have meaning, so it makes sense with the problem. Now I'll have to preface this though. I did pull this example from an intermediate algebra textbook. I'm just going to say this right now. This word problem that I wrote down is not meant to be some sort of political statement. I am not trying to make a political statement one way or another about guns or gun control or anything. It's a statement about a poll that was taken by ABC News. Right. So this in no way reflects any political opinion I may have. Right. And I hope I'm not being insensitive to people who feel one way or another about guns or gun violence. I am not trying to start an argument. All right. This is simply for the solving of an absolute value inequality and then interpreting it. Okay, so just yeah, don't take this too seriously. So this problem I pulled, it says, in a poll conducted by ABC News, 9% of Americans stated that they have been shot at. The margin of error, we'll talk about that in a second. The margin of error in the poll was 1.7%. So if we let P, right, so the variable here is P, if we let P represent the true percentage of people or Americans, right, who have been shot at, we can represent the margin of error this way, as this inequality here, the absolute value of P minus 9 is less than or equal to 1.7. All right, so we're asked here to solve the inequality and interpret the results. Now, if you know what margin of error means, you can actually state what the solutions about this are really quickly. When I say margin of error is like a tolerance, like the 1/32 from the previous problem. It's a give or take number. So suppose I have here's a number line, and they're telling us that in the poll 9% of Americans stated they have been shot at. So let's say here's where 9% is. Let's put 9. You can put this 9 here because remember P actually represents percentages. So 9. Then the margin of error is the tolerance on this, the give or take. So they're saying like it's 9% say they've been shot at, and the margin of error was 1.7%. So that means that like how much you could be off, right? How much that could be off from the true amount of Americans, true percentage of Americans that would have actually been shot at. Because this is just 9% of the people in the poll, right? So of the people that were asked, right? So maybe 100 people were asked, and 9 of them said they were shot at, right? That's 9% of the poll. And then you have give or take, right? Because they're not asking everybody in America, right? They're just asking so many people in this poll. 9% of the people in the poll said, and then this 1.7%, this margin of error, is like an amount of error, amount they could possibly be off, amount they could be wrong for the entire country for real. So the amount of the percentage of people that are shot at could be 9% plus 1.7% or minus. It's a tolerance on both sides, or minus 1.7%. So if I take 9%, plus 1.7, that'd be 10.7%. Would be like the high end of my interval here. And then 9 minus 1.7% would be 7.3%. Right. So basically, what this is saying is that the true number, the true percentage of Americans who have been shot at is based on this poll somewhere between 7.3% and 10.7%. Right. That's what margin of error means. It's 9% with a margin of error of 1.7. That means give or take 1.7% away from that 9%, and you'll get a range of values that should actually contain the true percentage of all Americans who have been shot at. Right. So if you know what margin of error meant, you got your answer pretty quickly. But what we're asked to do, though, all right, so I'm gonna cover this up. What we're asked to do is solve this inequality that was given, where P represents the true percentage of people who have been shot at. And, solve for P and then also interpret the results, write out in a full sentence what it means to you, what it actually means to this problem. All right, so we're starting off here with the absolute value of P. All right, this is getting pretty faint. Sorry about that. So we have the absolute value of P minus 9 is less than or equal to 1.7. And this is very similar to the first example I went over, right, where we have the absolute value of some expression, the absolute value of a number represented by expression is less than or equal to some number, some non-negative number like 1.7. Right, it looks like this. Right, it looks exactly like this with the absolute value of some a, where a is this P minus 9 is less than or equal to some number n, where n is 1.7. And what we do in this case is, I isolate the absolute value, which it already is, it's already alone, and then I rewrite it as an equivalent compound inequality, right? And this will be one of those connected inequalities here, a compact inequality with the word and involved. So to say that the absolute value of P minus 9 is less than or equal to 1.7 means that P minus 9, right, the number inside the absolute value symbol, has to be closer than 1.7 units to 0. Right, that's what absolute value less than 1.7 means. So we have to be between negative 1.7, right, that's 1.7 units away from 0, and positive 1.7, right, that's also 1.7 units away from 0. So anything in between those, right, would have an absolute value less than 1.7. And also equal, right, we have the or equal to, so we can have an absolute value equal to 1.7, so or equal to, or equal to. All right, so now that I've set up this equivalent compound inequality, we solve it. Right, and again, it's like the earlier example. I find, get the variable alone in the middle, and what I do to the middle, I do to the outsides as well. So the only thing that needs to be done here is the addition of 9. All right, so the addition of 9, and what we're left with is, I've got P in the middle is between. Then on this left side, this is 9 minus 1.7. That's 7.3. And this side is 9 plus 1.7. That's 10.7. And we have the variable alone. Here are the solutions to this inequality. All right. This inequality will be a true statement if I replace P with 7.3 or 10.7 or any number in between. All right, so now I have to write about, what does this mean in relation to this problem? All right, so what did P represent? Remember, P represents the true percentage of people, true percentage of Americans who have been shot at. So if I write this out in words, what this actually means, actually interpret this result here, what this is saying is that, so how I would answer this question is, P, right, which represents, the true percentage of Americans who have been shot at is between 7.3%, right? Remember, P is representing percentage here, so these numbers are in percent. So the true percentage of Americans who have been shot at is between 7.3% and 10.7%, and again a little comma there, and because they're included, I'll say inclusive. All right. And this is exactly what I talked about on the first page of this problem, right? When we talked about, what does margin of error mean? The poll said 9%, but with a margin of error 1.7, so you got the give or take 9%, give or take 1%, 1.7%, and you see my 7.3% and 10.7% there in the picture from the first page. Well, that's exactly what we're getting here with our solutions to this inequality. So there you go. This is the way I would answer this. And just as a little side note, right, this between 7.3% and 10.7%, this is the 9% give or take, right, your margin of error, give or take 1.7%, right? And you can see that in the inequality. I mean, you can see that in the solving of the inequality too, right? See how the low end had the 9 take 1.7 away, and the other side of the inequality had 9 give the 1.7, 9 plus 1.7. So 9% give or take 1.7%. You get your true percentage of Americans who've been shot at is between 7.3% and 10.7% inclusively, right, or just inclusive. Great. All right. And as I said, you see this problem here, the first problem. Anytime you have a word problem or an application problem, applied problem, however they word it, you should be answering your question in complete sentences where and every number you write that's related to the problem should have units attached to it, right? Percent actually means something here. It's out of 100, right? Percent. But your numbers, the numbers you write should have units, right? So that it actually gives the numbers meaning in relation to the problem. All right. And as I like to say at the end of these videos, please try your best, do the best you can to learn the material on your own before you go looking for help. I find that people who take the time and effort to learn things on their own, tend to remember it for longer and remember it better when they need it. So read the material, of course. Read through the author's examples. Perhaps even work on the solutions to an author's examples before you see how the author did it. And then compare your work to the author's and see if you can learn something from your mistakes there. And obviously work on plenty of exercises, practice problems, check solutions when they're made available so you can see how you're doing. Keep track of your progress. And don't just give up on a problem after the first attempt. Usually there are many ways to go about working a math problem. So if after several attempts, several approaches at a problem, you're still not getting it, it's still not making sense to you, perhaps you should read through the material again, more slowly, more deliberately, take notes, maybe even a third time read through it. Because after you work on some problems, usually you have a better idea as to what the author wants from you, so then you know more what to look for in the reading. So you go back and read through a second time or even a third time, and you'll probably see some things that you didn't see the first time, or some things will click that didn't click the first time through, and it'll just make working on the problems that much easier. But if after that, if after several read-throughs of the material and several attempts at the problems, you're still not getting it, still not working out for you, well, then it is not a sign of weakness whatsoever to go looking for help. That is what other people are there for. So ask a teacher, a tutor, a friend, someone in your class who you know knows the material well and is willing to help. Look for supplemental materials online. There's loads of it out there. Look for videos online. There are lots of videos out there on math subjects, like this one, or plenty of other ones out there that are better than these that I'm putting out. I promise you can find them pretty easily. But just keep at it. Stay persistent. Keep practicing. Don't give up. And I think the hardest part is to keep a positive attitude about a subject, especially one that you think is boring or that you've hated your whole life or you think you hate. Because if you keep thinking that it's going to be boring, that you hate it, that I always hate it, I'm going to hate it, you're probably going to continue to hate it, it's going to continue to be boring, and you're not going to get anywhere. So just, try to go in with an open mind. Try to go in thinking I'm going to enjoy learning, I'm going to learn something today, and I'm going to read this, and I'm going to take something from it and use it in my life, use it in my school, my class, and just have fun with it. It's amazing the difference a change in attitude can make in the learning experience. So try to keep persistent, keep practicing, stay positive, don't give up, and I just know you can get it. All right, thank you very much for watching.